Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll go through antiderivatives of exponential and trigonometric functions. So let's start with the trig functions. So you know that the derivative of sine x is equal to cos x, right? We all know that. So another way of saying this, so if I differentiate sine, I get cos. Another way of saying that is if I integrate or anti-differentiate cos, then I get sine. And remember, this means integral, so the integral of cos x, integral just means find the antiderivative. So similarly, you know that the derivative of cos x is minus sine, so that means that the integral of sine x is going to be minus cos x. So when you differentiate minus cos, you get positive sine, so that's why this formula here works. So how would we do something like this? The integral of cos 2x dx. Remember that dx just tells us we're integrating with respect to x. So we know that this would have something to do with sines, right? So it would be sine of 2x to start with. Because when we integrate cos, we get sine. And you know, when I differentiate sine of something, the thing in the brackets doesn't change. But if I were to differentiate this using the chain rule, I would have to multiply by 2. I'd have to multiply by the derivative of what is inside the brackets here. So when we're integrating, anti-differentiating, we're doing the opposite. So instead of timesing by 2, we're going to divide by 2. So remember, when you're integrating, what you need to do is always add a c. You add a constant to each of these formula because remember, when I differentiate, constant vanishes, so this number here can be absolutely anything. So if I were to differentiate this whole thing here, the constant would vanish. Here, I'd go 2 cos 2x over 2, 2's cancel out. If I differentiate this function here, regardless of what the number is there, then I would get this function here. How easy is that? All right, let's move on to exponential functions. So you know the derivative of e to the power of x is itself. We've gone through that. So that, of course, means if you integrate e to the power of x, you get itself, but we need to add a constant. This constant can be any number. So how would we use this to integrate something like this? So the brackets here mean that we're integrating all of this with respect to x. So remember, when you're integrating functions that have more than one term, you just go term by term. So we're going to integrate this one, then this one. So starting with e to the 4x minus 3. So you know when you differentiate e to the power of something, you get the e and the power doesn't change. So same when I integrate. If I want to integrate this, it's going to have something that looks like this. Because when I differentiate this, the e and the power won't change. Now, if I were to differentiate this here, remember I'd have to times by 4. That's what the chain rule says. I'd leave the e and the power, but I'd times by the derivative of what's in the power, which is 4. So that's if I wanted to differentiate, I would times by 4. So if I'm going to integrate, I need to divide by 4. So if I differentiate this function here, I get this one here. So that's the first part done. Now, what's the integral of 2? Well, we saw that in a previous video. This is like a polynomial. It's just 2x. So that hasn't changed. Even though we're talking e's, coses, and sines, the integral of 2 is still 2x. And we need to put a plus c at the end because we can add any constant. And then we're done. If I differentiate this, regardless of what the value of the constant is, I would get this function here. So one point I just want to make is if we had to do something like this, it looks easy but incredibly tricky. E to the power of x squared. That's very tricky. See, what a lot of people think they do here is they think, okay, so I'd have e to the power of x squared, and then I divide by 2x, because if I wanted to differentiate e to the x squared, I times by 2x. Now, you can't actually do that, because if I wanted to differentiate this, I'd use the quotient rule. It would get messy. We're not going to look at functions like this, but I just wanted you to understand. The rule here, instead of timesing by 4, the opposite of timesing by 4 is dividing by 4. But we can't just divide when we're integrating. We can't just divide by x's or times by x's, because that makes things very complicated. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.